Hello everybody. In this video I'm going to show you the equilibrium of a particle for 3D cases. Okay, so you can see I already drew the picture for problem number F3-7 because this one is a very critical one. Okay, so you can see here, actually this is my y-axis, x-axis and z-axis. I have 5 forces here, F1, F2, F3. Then I have one force here, which is 600 Newton along the positive x-axis, and I have 900 Newton, which is along the negative z direction. Okay, so if we want to find out the forces like F1, F2, and F3, these are the three unknowns here. For 3D cases, actually I have three equations here, which is summation of fx equal to 0, summation of fy equal to 0, and summation of fz equal to 0. So I have three equations, and you can see I have three unknowns, so it can be done, right? So first of all, I have to express all the forces in terms of force vectors, and then I'll add all the I term for summation of fx, and for j term, for summation of fy, I'll add all the j term and set that one equal to 0, and then I'll add all the k term for this one and set that one 0, so I'll get three equations. I'll solve that one and find out the three unknowns here. Okay, now let's start with F1. So how can I express that one to Cartesian vectors, right? So you have to always look at that. Like this is actually, if you go to the head of this force, you can see this, there is a parallelogram or a rectangle here. That would actually show that which plane this force is working. So you can see this is actually YZ plane. Means like F1 has only component in the Y and Z and doesn't have any X component, right? So if you see here, then this one will say like 4/5 of that F1 is in the Y direction and 3/5 of F1 in the J direction. So I can write that force vector here, that F1 0I plus 4/5 of F1 J plus 3/5 of F1 K. So that's the presentation of the F1. Now if I go to F2, then basically you see this one is just working negative direction of x, so you have only F2I here. The other two is 0 and 0 because that's along the line of the x-axis. Okay, now this one is the most important one, like F3. If you see that parallelogram here, then you can see that actually the F3, if you take the vertical component of that one, that will go to Z direction. If you take the horizontal component, that actually come along that line, green line here, okay, which is actually XY plane. Although Y is negative and X is positive, but this is basically Y direction. Actually, let me. Okay, so first of all, if you take the 4/5 of this one, that's actually the z-axis. Okay, so let me write that one here. I'm writing the z-axis first. That's actually 4/5 f3. Now, if you see like that green line, that actually, like the projection of that line in the xy plane, which is actually 3/5 of f3. So this green line, let's say this is AB. So AB is basically 3/5 of f3. Now you can see actually like we have like this one is, if you see this one is like if you dissolve that one into y-axis and x-axis, then basically you see that y would be 4/5 and x would be 3/5 here. Actually I should draw that one a little different here. That's actually 90 degree. Okay, so you can see along this axis is 3/5. So 3/5 of AB, that's basically 3/5 into 3/5 of F3 I plus 4/5 of 3. Actually y is negative here, so I'll just put that one negative. 4/5 of AB, so which is actually 4/5 of 3/5 of F3. So that's basically my F3 here. Then I can also show this one, this force, which is actually nothing but minus 900K, and this one is 600I. Now what can I do? Like I have all the 5 forces is now in terms of Cartesian vector, so I can add the I terms, j terms and k terms and set that one to equal to 0, and then solve that one to find out F1, F2 and F3. Okay, so now let's see if I want to use this one here, then I can see I don't have any x component here. I have here just F2, and here is minus 12 by 25 F3. Oh no, I'm just adding the x term, so that's actually 9 by 25. I'm adding this term here, okay? F2I, this is 9 by 25 F3, and I have 600I. So plus 600, that's equal to 0. That's my first equation. Okay? Now, let me make this one a little bit more space here. So if I add the summation of Fy, no, not this one, actually this one is y. So you can see this one doesn't have any component in the y direction because this is along the x-axis. This one doesn't have any component in the y direction because this one in the z direction. So I can see here 4/5 of F1 then you can see this one is actually 0 and then minus 12/25 F3 0, and then you can also write the summation of forces in z direction. So here you can see you have 3/5 of F1 this one is 0, this one is 4/5 of F3, and then I have minus 900, that's equal to 0. Okay, so I have these three equations here, and we can denote that one as 1, this is 2, and this is 3. Okay, so actually if you simplify that one, then basically you don't need to write that one anymore. Okay, now if I first use this one here, you know, like F1 and F3 equation number 2, then you can see F1 is basically so you can make that relationship from here is actually F1 is equal to 3/5 of F3. Now if you plug that one in equation number 3, then you can see 3/5 and again F1 is 3/5 of F3 plus 4/5 of F3, that's equal to 900. Okay, so this one is 9/25 F3, and let's multiply both top and bottom with 5, so this one is 20/25 F3 is equal to 900, so this is 29/25 F3 is equal to 900, so F3 is equal to 900 into 25 divided by 29, which is actually F3 is 776. Newton. So now if I plug that value of F3 here, then my F1 would be 3/5 of 776, which is basically 466. Now let's try to find out the value of F2. So what we have to do is just plug the value of F3 in this equation. equation number 1. Actually, I made a mistake here. That should be minus f here. So if I plug that value of f3 in equation there, then basically your f2 is equal to 600 plus 9/25 into your f3, which is 776. So if you add them, that would be 879. Okay, so that is basically the answer here, f1, f2 and f3. Okay, now let's move forward and try to do one more problem here. Okay, thank you. Hello everybody, now we are going to solve problem number 3-48. You can see I already put that figure here. This is your x, y and z axis. There is a weight here which is 100 kg, and this load is supported by 3 cables A, B, AC and AD. So in this problem you have to find out the value or the tension in AB, AC and AD. Okay, to do that one, actually what I have to do, you can see here that this load is actually along the x-axis, this load is along the y-axis, and the load at AD, that actually we have to find out the position vector first and then the force vector to know that the direction of that force. Okay, and we also see the weight is definitely working downward, means like minus z direction. Okay, now to find out the position vector from A to D, we need to know the coordinate of A and D. The coordinate of A is 0, 0, 0, and the coordinate of D is actually this way, minus 2, 2 and 1. Okay, so any position vector from A to D, that would be D minus A, so minus 2I plus 2J plus K. So I have to now find out the unit vector from A to D, and to find out the unit vector I need to know the magnitude of my position vector AD. So that's actually 3. So the position vector from A to D, that would be minus 2/3 of I plus 2/3 of J plus 1/3 of K. So if I want to convert that one to force vector, then basically force AD is actually 2/3 of FAD I plus 2/3 of FAD J plus 1/3 of FAD K. Now I can also write the force vector for AC, which is from A to C in the negative direction. So this one is minus FAC J, because this one has only y component in this direction. Similarly, if I want to write FAB, then you can see that would be actually FAB I. And then if I want to write this one, that would be, let's say, weight. That's basically 100 into 9.81. That's negative K. Okay, so I have four, force here. I converted all of them into force vector. Now I can say like summation of I equal to 0, means like summation of forces in the x direction equal to 0, right? If I do that one, you can see summation of Fx equal to 0, so you can see minus 2/3 of AD. Then I don't have any ij component here, I component here, and then plus AB equation number 1, FAB actually, FAB, sorry. Similarly, if I add the j term here, summation of Fy equal to 0, so you can see 2/3 FAD and then minus FAC, and that's actually 0. And if I add the z term, then you can see 1/3 of FAD minus 981, that's actually 0. Okay, so you can see now I can just solve the three equations here and find out the force FAD, FAB, and AC. Okay, to do that, the easiest way would be solve the equation number 3 first. So you can see FAD is equal to 981 into 3. That's basically 2943 Newton, or you can say 2.94 kilonewton. Now if you go to here, then equation, plug the value of FAD in equation number 2. So 2/3 FAC is equal to 2/3 of FAD, which is 2/3 of 2.92. So FAC equal to 1.96. Okay. Similarly, if you plug the value of FAD in equation 1, then basically you see FAB is equal to 2/3 of FAD. Same thing like 2/3 of FAD, so that would be 2/3 of 2.92, so that would be 1.96 kilonewton. Okay, so basically the answer is like this one here. Okay, thank you for watching.